When multiplying polynomials, there are a few special products that come up quite frequently that are useful to us and have a nice little shortcut so that we don't have to go through all the work of distributing out every single term and combining like terms. The first of these is a sum and a difference. This is when we have something added and something subtracted. Notice they're the same numbers, a plus b times a minus b. Now, if we use the distributing method, we would see a times a is a squared, and a times negative b is negative ab. On the center, b times a, putting them alphabetically, is positive ab, and b times negative b is negative b squared. Now, we have these like terms in the middle that conveniently are going to subtract out to 0. Negative ab and positive ab are 0, and so we're just left with a squared minus b squared. And so what we notice is when we're multiplying a sum and a difference, where the numbers are the same, one's plus, one's minus, we can just square both of the individual parts and then put a subtraction in the middle. For example, if we have 4x minus 6 times 4x plus 6, noticing that that's a sum and a difference of the same things, we just say 4x squared is 16x squared, subtract, and square the 6 is 36. And we're done that fast. So we square everything and then always put a minus in the middle. The sum and difference shortcut. Another shortcut that's not quite as obvious at first, but turns out to be quite useful as we get used to it, is when we square a binomial. A plus b squared. First off, I want to remember that squared means we multiply by itself. A plus b times a plus b. And so when we try and use the FOIL or the distribute method, we're going to take a times a, we get a squared. A times b, we get ab. Distribute the b through, we get another ab, putting them alphabetically. And b times b is b squared. Now, when we combine the like terms in the middle, this time they don't go away. Instead, we have 2 of those ab's. So we have a squared plus 2 of those ab's plus b squared. So when we square the binomial, we end up with the first term squared, twice the product, and the square of the last term. Really important, I want to note that it is not a squared plus b squared. We do not distribute that squared through. Because when we distribute, we lose that middle term. Batman and Robin even discussed this. When Robin said a plus b squared is a squared plus b squared, Batman slaps him across the face and says, no, it's a squared plus 2ab plus b squared. In fact, it gets even worse, that every time you take that squared and put it through onto both parts and lose that middle term, they say that somewhere a puppy dies. Do not be responsible for the death of a puppy. Never just square the pieces. We cannot distribute exponents. It does not work. Whoops. My writing's in the way here. Let me erase that on my notes. So when squaring a binomial, we square the first term. That's pretty straightforward. Then in bold and underline, this is the part people forget. We take twice the product. The product's there twice. And then we square the last terms. So for example, if we have 4x minus 6 squared, we can square the 4x. That's 16x squared. But then we need to multiply them together. 4 times negative 6 is negative 24x. And it's going to be there twice. Negative 24 and negative 24. Twice the product is negative 48x. And then we can square the last term. Square the 6 to get 36. Square the first term. Take the product twice. And square the last term. So let's take a look at a couple more examples to kind of wrap this up. This first example, you'll notice we're taking the same stuff, but a plus and a minus. It's a sum and a difference. 5x squared plus 8, 5x squared minus 8. With a sum and a difference, we do square all the pieces. 5 squared is 25. X squared squared, when we square the square, x squared squared, we'll multiply those exponents to get x to the 4th. Always subtraction with a sum and a difference. And 8 times 8 is 64. The second example is squaring a binomial. So we square the pieces. 6 squared is 36. X cubed squared, again, x cubed squared. When we're squaring an exponent, we multiply them. So that's going to be x to the 6th. Don't lose the product. 6 times 5 is negative 30. X cubed y squared. And it's there twice. Negative 30. X cubed y squared. So 30 and 30 is 60. Minus 60. X cubed y squared. Don't forget the middle term. Multiply them together. You have that twice. And then negative 5 squared is 25. And y squared squared is y to the 4th power. We have now squared this binomial. Square the first, twice the product, then square the last. These special products turn out to be quite useful to us as we work through our future study of algebra. So now's the time for you to get familiar with them to give you an advantage moving forward. The sum and difference and the perfect squared. Take a look at them on your homework assignment and let your instructor know if you have any questions.